So today should be a fun lecture on all the kind of cool things that have come out of these cutting edge stable diffusion and other methods that we've been talking about, right? So especially stable diffusion, right, enabled people to easily make new like kind of mini projects and checkpoints and so on and import them into the models that people could run on their own computers, right? With something like Midjourney, you're kind of stuck with whatever they use to update the model, and the same is true with, you know, like Photoshop and DALL-E 2 and DALL-E 3 and so on, right? But I want to talk a little bit about some of the cool things that people have been doing with these diffusion models, right? So kind of the first thing is, sorry, I have to do my little thing. Come on, focus. There you go, should have done this before. All right, so this is kind of generally called diffusion developments, I would say. So one thing that you can do pretty much any thing that you choose is inpainting, okay? So inpainting is a concept that you know, I talk about when I teach regular image processing, and kind of in the mid-2000s, there was a lot of interest in automatic image inpainting. And the basic idea is that you have some original image, here's a guy and he's holding a, phone. Then you basically have a mask that you kind of say, okay, this part of the image I want to replace. And then now the way that this would work is we would also supply some sort of a text prompt. Let's call that D. And then this, along with these three things, goes into some sort of a model where now you've got you, and you could be holding, a cup of Starbucks or a cat or whatever, right? So let's call the original image X, and the new image, let's call it X hat. And then this mask, let's call M, okay? And this is a binary mask where it's basically 0, where I want the image to stay the same, and 1, where I want the image to change, okay? And so there are a lot of ways you can do this, but kind of the easiest way is in a paper that I mentioned in, well, I mean, there are many ways of doing it, but like, I think a nice explanation is in this paper that I believe is on last lecture's course page, due to Avrahani et al. This was a CVPR 22 paper. People have been talking about this for a long time. So here's the idea. So kind of what I want is to think about the element by element multiplication of these two images, okay? So what we want is, if I take the image that I create and I multiply it element by element with M, that's just going to be the region around the new object, right? It's only going to be 1 in that region and 0 everywhere else. So we want this should be consistent with the text prompt, which I'm going to call D, okay? And we want the multiplication of, if I look at 1 minus M, that's everything but the inpainting region. This rest of it should basically be, whoops, sorry, no hat, more or less the same as the original image, right? So this is the new, and this is the old, right? And then we want kind of a seamless transition between those two regions, right? So the algorithm that I used to teach in image processing was an algorithm from Cremonesi et al., which was like 2004, right? So it's 20 years ago. And the way that that algorithm worked was more or less by trying to take pieces of the image around the inpainting hole and try to kind of paste pixels that seemed reasonable into the hole until the hole was all filled up, right? But now with our kind of world of prompts and diffusion models, that whole old algorithm is probably out the window, right? Modern algorithms can make inpainting so much more convincing than these old ones did, right? So this kind of suggests a loss function like the following, right? So, so if I wanted to have a loss function that kind of mimicked or kind of mirrored this philosophy, this would be like saying, I want the distance, for example, like the cosine distance, between the clip image embedding of the new image in the mask region and the clip text embedding of the prompt to be similar, right? I want these things to be low distance, right? And then I have a weighting that says I also want the distance between the old image in the mask, in the outside of the mask region, and the new image in the outside of the mask region. I also want this to be low, right? And this could be some combination of mean squared error or LPIP's distance or something like that, right? So I kind of want things to be consistent in the old region, and I want things to be consistent with the prompt in the new region, right? And then the blending part, to make sure the boundary is invisible, is kind of done step by kind of diffusing in the latent space. So there's a little bit of extra secret sauce to make sure that the boundary is not visible, okay? And then there are a whole bunch of augmentations to make sure that this process is robust. So for example, what you could do is you could kind of take projective transformations and warp these two things around to make sure that the inpainting process is good. And so this you can do in many ways, right? So for example, well, actually, before I talk about this, well, we could do it on my local machine or on Photoshop. Before I go on to that, let me just say that the same idea applies to what's called outpainting, right? So outpainting is something that I feel like people didn't talk about too much until all these diffusion models. Outpainting is basically kind of like saying, I have my original image, and now what I want to do is I want to hallucinate what happened outside the frame. And that outside part could be conditioned on a prompt, or it could just be kind of like trying to make something that looks harmonious. And so typically, you don't go from like a tiny image to an image the size of this piece of paper in one shot. You do it kind of like incrementally, adding little bits and pieces of stuff each time, right? So I just got an email from Adobe this morning saying, try our new algorithms out in Photoshop beta. So let's take a look. So this is a picture I took of these women dancing on a farm. And so if I, let me just kind of make this a little bit smaller here so that you guys can see it. Okay, so you can see that, this image is not like entirely centered, right? So what I could do is I could hit the crop button here, and you can see now in Photoshop, I'm not sure why you don't see this thing. I see a little thing on my monitor, but maybe it's below your vision in OBS, in this thing. Maybe if I bring this up, you can see it. Hold on. Problem with Photoshop is there's like a zillion layers of stuff, so I don't know if I can make this any better for you. Nope. All right. Well, anyway, trust me when I say there's a little button out of your field of view that says Generative Expand. And so you're going to see the effect of it, where basically I can drag this out. So now I'm kind of centering these dancers in the frame. And then it's giving me a question like, what would I like to generate? And I'm just going to say generate. I don't care what, I don't care what's going to go in there. I just want something that's consistent with the image. As you can see, for example, that there's this person, hat is kind of cut off in the background. And in the foreground, there's this house in the background. And hopefully, when it does the completion, which is almost done doing, it will give me something that looks pretty good. Right? So here, this is outpainting, right? And of course, I could make this image even bigger if I wanted. And then the same thing I can do is inpainting, right? So if I kind of select a region, I could kind of like say, OK, I'm going to draw a region around here. And then the first thing that pops up now is this thing that says generative fill. And so I can say, a happy dog, and then generate. So again, you can't see the full Photoshop window just because your head would explode. There's too many knobs and whistles, but it's almost done generating a bunch of options for me to take a look at. And then I can choose which one I like. Almost done. Here it comes. OK, so that's a pretty happy dog. This dog here is all right. This dog here is all right. And all those things look pretty consistent with the background, right? This dog has a kind of a weird face, I guess. I think this is a nice dog. All right. And then, of course, if you put in stuff that isn't really, like realistic. So here, for example, let's put in, a giant transformer, right? So that's probably not going to be very consistent with the rest of the scene, but we'll see what it does. And then, it's always asking me, have I got feedback? I guess the problem is that you don't actually see all the little Photoshop windows that are popping up in addition to the main window. That's why you don't see it. But it's all right. So let's see what we got here. I don't know what that is. It doesn't look like a transformer, though. I guess that's a transformer of some sort. It looks like a bike rack. Hey, transformer. All right, that's not bad. But I mean, here you can see, for example, that the lighting and the style of this thing doesn't look at all like, I mean, the background blends in okay, but like it doesn't look like it belongs in the scene, right? So I think if I ask for something that's more realistic, like I'm going to type in a flowering shrub and see what it comes up with that, I think that probably will make things that are a little bit more harmonious with this kind of like barnyard background, right? So let's see what we got. I don't think it's so great at doing like faces and so on. Like the first time I tried this demo, like it generated some really creepy looking dogs. Oh, hey, look, this is not a shrub. This is like the same person who's jumping around, right? This is a shrub. This is a shrub. I don't know. None of these look like super realistic. Like the lighting is not so great, right? So clearly, there's a little bit more to do to make this work, But I mean, the fact that it works at all in a matter of seconds is pretty impressive, right? So the same kinds of ideas we can do in like Midjourney, for example, but the interface is a little bit clunkier. So if I go to, let's see, I've got a Discord, right? So if I say, imagine, I don't know, a bunch of dancers dressed like carrots, which is kind of what we were looking at before. And I guess while we're waiting for this, we can also hop over to Stable Diffusion, right? So Stable Diffusion, I am no Stable Diffusion expert. There's like so many knobs and stuff here that I don't even know what to do. So I think basically what you could do is to say, again, let's try the same thing. What did I say? A bunch of dancers, a group of dancers dressed like carrots. Let's get some stuff generating over here. That was pretty fast, actually. Although, I don't know if I'm waiting for one that I really like. Oh, this is the one. It's a quality image. So, okay, so now we got these carrot dancers. So, all right. So now what we can do is we can say send to Inpaint. And then I can draw a region here. And so let's see, I can kind of, and this is definitely, as you can see, a little bit less polished than Photoshop is. And let's put in here like a, and then I guess what you do is you prompt it with, I think that you prompt the whole thing, I'm not 100% sure, with a man dressed like, broccoli. So I believe what it's supposed to do is just inpaint in that region. I may have messed it up, so. It doesn't look like it did anything, actually. Let's see, inpaint mask, blah, 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 inpaint area, only masked. I'll try that again. I thought it was working before. No, I don't see any like broccoli action. I must be doing it wrong. Let's go over and see what I'm doing in Midjourney here. So Midjourney has returned a whole bunch of other stuff. Here are these carrot dancers in Midjourney. I think that the fourth one is actually pretty good. So let's take the fourth one, and then I believe that once this works on upsampling this one, now you can say, let's see, how do you do the inpainting? I did this yesterday. How do you do settings? As usual, there's like many things in these. Yes, remix mode is what I want. So how come I can't remix my carrot here? This is very region. That's what I want to do. Yeah, so Midjourney provides a very kind of like coarse masking region. And I can say, with a guy dressed like a broccoli. And then I guess it will give me a bunch of variations on that theme. So it's working on that. Yeah, I don't exactly know what I did wrong here in Stable Diffusion, but as you can see, there's like a zillion knobs and levers and so on. I'm not exactly sure how to do it. But that's the basic idea. And so, of course, you know, the Adobe Firefly stuff is actually pretty well engineered, right? Because clearly people already know how to use the Photoshop workflow and so on. Where's my broccoli man? I guess this is the broccoli guy here. Do we think this is like a... I mean, I guess this guy here is new in the lower right-hand corner. Oh, no, he's holding a broccoli. That's right. Let's take a look at this guy more closely here. Yeah, he's holding a broccoli, I think. So anyway, so that's the basic idea: inpainting, outpainting, right? Okay, another exciting development that basically happened over the past year or so is the ability for you to train a diffusion model on your own face or on some other object or something like that. And so this was the result of a couple of very popular papers, right? So basically, there was one called Textual Inversion, which was by Gal et al. Just this year in ICLR. And so this was applied to basically like latent diffusion or stable diffusion. And so the idea is that you know, we know the general idea. We got D is our text prompt. And let's call embed of D my text embedding process, whatever that is. Could be clip or could be something else. And so now the way that this works is, and before I go on, let me just kind of show you what the outcome is going to be. So this is actually the same kind of thing I was just showing you, inpainting and outpainting. So this is textual inversion, right? So the idea is that you show it a bunch of examples on the left of some item that is basically not in, you know, it's not an obvious, an easy to describe item, right? And then with only a few examples, like 10 or 15 examples, now you can use this special token, S star, that you can ask for an oil painting of this, an app icon of it, you know, Elmo in this pose, you know. And so the idea is that it learns specifically what this thing is, right? And in a way that would be very difficult to describe if you're trying to describe it from scratch using a text prompt, right? Like you'd never be able to do a job of generating this picture from just a text prompt alone. Instead, you kind of like teach the embedding process, hey, I'm showing you this new thing, and here's what it is, right? And so how does that work? So the idea is that we assign a dummy token, let's call it asterisk, whenever we see the phrase or this or the, you know, the thing S star in the prompt. For example, we might have a prompt like, you know, an oil painting of S star, okay? And the idea is to learn a good embedding of this token. So we want to learn an embedding, let's call it V star, of this asterisk, to kind of remember this new concept. We don't want to otherwise retrain or touch the existing text encoder or the latent space decoder. We just want to learn this one new concept, okay? And so the kind of process is the following, right? So I take my prompt, right? So I've got like, you know, a photo of S star. that kind of gets turned into, you know, a bunch of tokens. And then this goes into, you know, a bunch of token embeddings. And a photo of goes into stuff that we already know we don't want to change, right? And then this thing is going to go to a new embedding V star that I want to learn. And kind of conversely, I want to lock all this other stuff, right? So this stuff is locked down. So I'm not relearning this. And then this all goes basically into the usual process, right? I've got some sort of an encoder, which is like a text transformer in this case. And then I have a decoder, which is like my latent diffusion generator. So this is like, you know, this is a text transformer. This is a latent diffusion generator. And then I get my output image. And so the idea is that all this other stuff is also still locked, right? I don't want to retrain this. I don't want to retrain this. The only thing I want to do is learn this one embedding of this new concept. And then during training, you basically are not just doing it with a single thing like this. This is, again, we talked about prompt engineering before, right? So if you read papers like DreamBooth, or sorry, like Textual inversion, and DreamBooth is what we're talking about next, basically you have a bunch of, you know, things like a photo of S star, a rendition of S star. You basically, you know, initialize the embedding with the embedding for the general class. Right? So in this example here, the general class of this may be sculpture in the upper left. And the general class of this other thing may be like toy or cat or something like that. And the idea is that that gives the initialization process something to work with. It knows this is a class of thing, and then it kind of refines that particular concept to be better, right? And so you could also do this in terms of like, you know, in the style of something else, right? So here there's, you know, these teapot, this singular teapot, right? But then they ask for like an S star watering can, right? So it's not a teapot anymore, it's like a watering can in that style, or the S star Death Star, right? And then there's another example of a child's drawing, or a bunch of different child drawings. And actually here, I think this is actually the same drawing that's just been like augmented with crops and expansions and so on. And then you could ask for, again, different things in that style. And then you could combine this with inpainting, right, which we just talked about, to say, okay, you know, now I can kind of remove an object and I can fill it in with the thing that I want that I just learned, right? So here you can have Steve Jobs holding this cat sculpture, right? So the whole thing is pretty slick. It does take a long time to learn the new concept, right? So I did this downstairs on our Stable Diffusion installation, and it definitely took like hours and hours on that machine to learn. But I did successfully learn, well, kind of successfully. So if we go back to, you know, this, I can say, you know, a Radke, you know, holding an ice cream cone. And it's not an ice cream cone. I mean, it looks like me, kind of. Here's two Radkes, happy together. Eating some chips or something like that. Here's another couple of Radkes. And we got ice cream. So, you know, it's not perfect, let's say. And I don't know why. I mean, I guess I have to say that all the pictures that it seems to generate have me with my eyes closed like this. And I don't think I look like that in the pictures I put in as input. So if I look at the pictures I put in as input, you can kind of see that these are the pictures that I put in. And I think I have my eyes open in some of them. I guess you can kind of see that some of them. But anyway, so it seems like it kind of learns this kind of squinty look for some reason. But it does produce hilarious results. So like, you know, especially like the ones with the double Radkes. Here it's, also I seem kind of toothy in these pictures. Hey, it just seems like it's happy for me to be together with myself and this ice cream. So you can try this and see how it goes. And of course, there's many, many things that you can use to try to manipulate this, right? So after this came out, then there was, well, I wouldn't say even after. It was almost simultaneously. There was a similar algorithm called DreamBooth, right? So DreamBooth was a project that Google was involved with. I feel like Dream, if you look at papers, is like a Google thing, right? There was Deep Dream, DreamBooth. There's another one. What's the one I'm going to do next time? I don't know. There's at least 2 other Dream papers I know of. Diffusion, I think, is one. And so basically, basically more or less the same time. This was by Ruiz et al. And was in CVPR this year, just a couple months ago. But of course, as soon as it came out, it went on GitHub, and everyone started to use it before it was even accepted for publication. And so basically, the idea is, you basically have the same kind of idea. You have a identifier, which is the unique thing, and then you have a class. So for example, for me, it would be a Radke man, right? Or a, fluffy, if my dog is named Fluffy, it would be like a fluffy dog. So again, this is kind of taking the role of the token or the asterisk from textual inversion, right? And so the idea here was that they looked for rare tokens to assign to the identifier string. So the kind of idea was to use some kind of existing stuff in the tokens that were never getting leverage and kind of take one of those and assign it to the string, right? And so the key difference was that textual inversion was only optimizing the new embedding of the concept. DreamBooth is basically fine-tuning the parameters of the diffusion model on top of that. So basically, this is fine-tuning the diffusion model. Using basically this idea of class noun images to regularize. And the claim is that it trains much faster and that, of course, this depends on your machine. It also produces better images. That was the claim. So if I look at some pictures from DreamBooth, it's kind of a similar approach, right? You take pictures of your cute pet and you say, show me him in the Acropolis or in a doghouse or getting a haircut, right? And then the kind of same ideas where you could say, and here you see the same kind of idea where this V is playing the role of the identifier, and then you've got the class noun, right? So it's like saying these are V sunglasses, right? So you say a V sunglasses worn by a bear, or a V sunglasses with the Eiffel Tower in the background, and this is a V backpack, right? So it's a little bit more maybe finer detailed in terms of telling it what the class noun should be. So I guess the disadvantage of this is that I guess I don't really know whether or not you can use it directly, because textual inversion got built into Stable Diffusion pretty fast, but I'm not sure about DreamBooth. I mean, I guess instead of speculating, we could just do a quick check to see. So get off of these carrot people. So let's see. I don't know if I linked to the DreamBooth page here. DreamBooth. Oh, this is the DreamBooth paper. Well, yeah, actually, I'll do the thing that everyone was asking. DreamBooth Stable Diffusion. Is it in there? People want to know. All right, so clearly there is a way to do it. I think part of the issue was that since this was a Google thing, they were using the Imagine text-to-speech or text-to-image thing, which is their version of DALL-E, basically. That's probably why you couldn't use DreamBooth directly. So people have tried to basically re-implement the idea. And this says this code repository is based on textual inversion while DreamBooth fine-tunes the whole model. So it's kind of like trying to use the architectural idea without actually using the same text-to-image model. So it's not exactly what you're going to see in the paper. So here, I'm not actually sure whether or not if you look for DreamBooth by itself, whether or not you can play with it. This is the GitHub repo, results, blah, blah, accessorization. Well, I don't see an obvious like repo where you can use it directly, right? Paper, dataset, BibTeX, right? I'm not sure what dataset is. So I think this is basically a data set that is just meant to help people directly compare their algorithms on the very same input set images, but you don't think you can actually get their DreamBooth results. So, OK, so DreamBooth was pretty cool. And then one thing that I heard people talking about here already is called ControlNet, right? So ControlNet is also super cool. So ControlNet is by Zhang and Agrawala out of Stanford. This was sometime in 2023, and the last I looked, I couldn't figure out whether this has actually been accepted for publication somewhere. I'm sure it's been reviewed somewhere, but I couldn't find an actual citation. And so the idea here is to combine the image generation process with conditioning on some orthogonal kind of, what's the right word, like input image, right? So the idea is to condition the image generation on, could be like, edge maps, kind of segmentation, scribbles, pose estimation. Seems like a very powerful algorithm, right? And kind of the idea is that if I go back to my slides, so ControlNet, the idea is that we have many, many examples of, like we can take any image and we can generate its edge map, right? That's just like an easy image processing operation, right? And so it wouldn't be hard then to train on a whole bunch of edge map, comma, image pairs, and then learn how to make a new image given an edge map, right? So the idea is that now I'm conditioning the generation on the edge map and a description. Same kind of thing here. So this is like more like a sketch of a turtle as opposed to the hardcore edge map. But still, like we talked about in the very beginning of class, like kind of non-deep learning methods for stylization, this I think is probably still automatically created from this picture, right? But then you could say, OK, I'm going to condition on pose, right? So there's lots of computer vision algorithms for taking a photograph and then estimating the human pose, right? And so I can take the image, and then I can go to the stick figure, and then I can say, OK, give me a chef in the kitchen conditioned on this pose, and it makes the chef in the same pose as this guy, right? And then you could do kind of things like this. You could imagine if I think about like color segmentation, I could have blocks of color, and then I turn it into a stylized version of that image, right? Which is pretty cool. And then this is something that like probably you saw one going around, but if you squint your eyes, you can see that I'm trying to get you to subscribe to my YouTube channel, right? So kind of like you squint and you see in black letters, watch my YouTube videos, right? But you kind of like relax your eyes, you just see a robot, right? So there was a very cool thing. I don't actually have it in this presentation, but you remember there was this one where you saw this like spiral of houses. You guys don't see it? I see it if I squint, yeah. But again, you would never know exactly what you were looking at if you didn't know what you were doing here. Yeah, so ControlNet, again, if I go to my notes for this thing. So ControlNet is, let's just go back to my website. Yeah, this is ControlNet. Adding conditional control to text image models. Oh, well, OK, I guess I just should search for ControlNet because that's the paper again. Here we go. Right. So ControlNet is basically, I took these papers obviously from here. ControlNet with canny edge, ControlNet with lines, ControlNet with boundaries, ControlNet with scribbles. I guess this was user scribbles, actually. So again, this is something where we take libraries of existing databases of kind of like photograph to X, right, where X is easy to obtain. And then we can generate new images conditioned on that prompt. And I don't know, actually, I don't think I actually have the interface myself here, which is too bad. This is the pose image. So how does this work exactly? Or how does it work more or less, right? So the basic idea is to build a duplicate of a pre-trained stable diffusion UNet, right? So the basic idea is to build a duplicate copy of the pre-trained stable diffusion UNet, right? So just a reminder that basically, stable diffusion is generating a whole bunch of images that are all the same size, and then there's like, a couple of blocks down here, and then I go back up the chain, and there's a bunch of skip connections, right? So this is my very sketchy UNet picture, right? And so the idea is that every time there is a block like this, right? So if I think about it, there are lots of blocks that are more or less like the following, right? I have, input. This goes into some neural network block. And then what comes out is some output, right? This is like one piece of the pre-trained network. Instead, what I do is I have the locked version of this. So nothing here is changing. This is all locked down. And then I'm going to add to this a different chain, right? So here, there is a condition. This is like your edge map or whatever. This goes into something that's called a zero convolution block. This is basically a 1x1 convolution layer that has everything initialized as 0. And then this goes into a block that is to be trained. And then, more or less, this gets added to here to produce the output. So every block in the latent diffusion UNet now has this little like side channel where the conditioning is coming in, okay? And they applied this to 13 of the stable diffusion blocks. So basically, they applied it to many things along the ladder, and I think they apply it to a couple of the things at the bottom, right? So applied to 13 of the UNet blocks of stable diffusion. One branch and then the middle stuff. And so basically, for every type of conditioning, though, you need to retrain the network, right? So you have to retrain this if you want to do the edge-to-image network. You have to retrain if you want to do the sketch-to-image network. And the retraining can take a while, but they suggested a lot of interesting computational aspects too. If you have a supercomputer, you should do this. If you have a cheap phone, you should do that, right? Or a laptop, you should do that. It still takes hundreds of hours to do the training for the given pair of stuff, or at least it did at the time that this paper came out. It may have gotten faster by now. And so this, again, generated lots of excitement, and I've been seeing these ControlNet-based things in like the Stable Diffusion subreddits and so on. So clearly, it's out, right? And I think that you can probably choose one of these pre-trained, ControlNet things. If you want to do your own ControlNet from scratch, it would probably be very difficult, right? But I think that the authors provide ControlNet checkpoints for various types of conversion, right? So if you're doing this on homework 4, I don't expect you to like retrain ControlNet. I just want you to use ControlNet to do something cool. Is that a hand?
Yeah. So this training process happens, like let's say I want to do pose estimation.
Mm-hmm.
It happens for that specific problem only, right?
Right. So basically, if I want to do it for pose, right? I take a huge library of people, and I run a pose estimator from some other algorithm to get these stick figure poses, and I take those pairs and I run them through the retraining of the diffusion model, right? And now I've got something that the stick figure comes in, and then I condition that on the text prompt like everything else, right? So, yeah. And so, yeah, I'm not exactly sure like, well, let me go back to my browser for a second here. I mean, it seems like maybe this is already built into Stable Diffusion because it's like Stable Diffusion 1.5 plus this, right? So I guess the question is, where do you get the things from? What?
It's an extension.
It's an extension. Okay. So it does all sorts of cool stuff, right? So again, the spirit of like, you can imagine that if you had like a training with your own data. Here we go. Here it says easy or even easier than training a simple pix-to-pix. So I don't know. Maybe it's not that easy, or maybe it's not that hard. So yes, let's go see how this works on your own stuff. OK, so a couple other things. So generally, the stuff I'm talking about here is all kind of under the umbrella of kind of like an image comes in and an image comes out, right? So for example, under Stable Diffusion, you'll see that there's like this text-to-image tab and there's this image-to-image tab where basically you can put in an image and then you can stylize it in a certain way, right? And so let's talk about that kind of functionality here. So more generally, and also less directly controllable, Stable Diffusion and some other things, like I think Midjourney has a version of this, include some sort of like image-to-image functionality, where you basically have like an input image, you have some sort of a prompt or a style, like cartoon or whatever, and then the goal is to make an output image, right? And so the general idea is that we have a fraction it's called alpha in the range of 0 to 1 that controls how faithful we are to the input. And the actual, so for example, 0 basically means we're most faithful. And the algorithm is actually very simple if you think about it, right? Because what we're doing when we do diffusion, right, is that we're training it with forward diffusion, right? We're taking the original clear image, we're diffusing that down to noise, and then to do reverse diffusion, we're taking the noise and we're diffusing it back up to clear image, right? So the idea behind this kind of like image to image is that you take your original image, you diffuse it down part of the way, and then you kind of add some prompt or some conditioning, and then you diffuse it back. And so the less you go back and the less you go down to the noise, the more faithful the result is to the original image. So if I kind of sketch that. So the idea is to do like alpha t steps of diffusion, right? So for example, let's say that t is my normal number of steps, 50, and alpha equals like 0.8, then I would do 40 steps. Meaning that I start with my photo or my input image, I add noise, and I do that for many steps until I get to the alpha t step. Now I've got something that is fundamentally pretty noisy, right? This is the forward diffusion part. Now I take this noisy image, and then I include my prompt, right? And now I'm going to denoise with reverse diffusion until I get back my output. So the idea is that even buried in noise here, the original image kind of lives on in some sense. And it's actually probably easier to show you just an illustration of this, right? So here, at the upper left, this says 50 steps, noise equals 0.8, right? Which means that I'm kind of going almost all the way to noise, right? And so if I stopped at 40 steps, I would get something that fundamentally looks like noise. Doesn't look like the guy holding the guitar anymore. And then when I diffuse it, if the prompt is like xenomorph playing guitar, I get something that is more like the pose of the guy, but doesn't really look like the guy at all, right? Whereas if I only diffuse halfway, right, 25 steps, and then go back the other way, this thing is more faithful to the original image than if I go further down the diffusion chain, right? So kind of I can control how much I alter the original image by how many diffusion steps I take before going back up the chain, right? And so that's kind of cool. What else do I have on this guy? Yeah. So that's the idea behind some of this image-to-image stuff. And I'm sure that if you look at the Stable Diffusion interface for this, and again, I should have worked on this before I came here. So like if I take, here's this, and I say like, smiling, sheep. I don't know. And then I think somewhere here is where I say to stop, right? So sampling steps. Well, let's just try it, see what happens. So, I mean, that is smiling sheep, I guess. I don't see how it looks very much like me, though. But I think that then you can play with how many, let's see, denoising strength. Oh, maybe this is the number. Let's crank this down. I really should have prepared this because I don't exactly know what I'm doing. Okay, well, so this looks more like a creepy version of me, kind of like creepy eyes. Ugh. So I'm wondering if I turn this up a little bit, whether I'll get something that's closer to sheep. Well, there's a sheep appearing now. Maybe I should be a little more generous here. So yeah, there's a lot of stuff to figure out and to play with. All right, well, there you go. I mean, that's definitely some sort of image-to-image thing going on there. That crazed screaming sheep. But the background is the same, right? So yes, entertaining. All right, so a few other things I wanted to mention, right? So like I mentioned, the fact that Stable Diffusion could be used by anybody meant that all sorts of people, especially, I wouldn't necessarily say like fine artists, but there are lots of like Instagram influencers and web artists and so on that are using this stuff, right? So one thing that came out kind of in the beginning of all this was called Disco Diffusion, which as far as I can tell was implemented by an artist in a collab notebook. And so I think this was popular before Stable Diffusion came out. And so it had a lot of good built-in tools for manipulating video, right? So that was one thing that was good about Disco Diffusion. So here, this is an example of the kind of stuff people generated with that. So you had these like super cool stylized video frames that were, not 100% consistent, but also like enough consistency that they looked cool, right? So if you want to play around with Disco Diffusion, I think it still exists as a collab notebook out there. The thing that got people talking, okay, so before I go on to the next thing, let me just also say, one thing that you may have heard of is LoRA. So let me just say, Disco Diffusion, this is kind of good tools for video clips. LoRA, which stands for low rank adaptation, was actually something that, again, came out of a totally different world, right? This was originally, I believe, a natural language processing contribution. But this is used for, again, this kind of like fine-tuning of Stable Diffusion models, much faster than something like DreamBooth. And so if you go to Hugging Face or somewhere, you'll find lots of these LoRA models for any sort of like style or person that you want, right? And kind of the idea is that you want to create, you know, a smaller model that can be easily shared. And so the idea is that if I have the original weights, W, of a big model, right? And then my fine tuning, I can think of like changing the weights by some delta. Now these weights are billions of weights, right? They're huge. But the observation was that I want to represent this delta W as the product of two matrices where each of these matrices are very low rank, meaning they're not like dense matrices that have all their singular values, right? These guys are much easier to store, much easier to train, right? And that's kind of like the idea behind the LoRA is that even though this may be a very large matrix, it's represented by two very simple low rank matrices that can be kind of like optimized on their own fairly quickly. And then the last thing I'll say is that people have done a lot of cool things by combining all the stuff we're talking about with kind of like a more traditional, what I would call like compositing or visual effects pipeline. So kind of the thing that made waves just this summer was this video by these guys, Corridor Digital, right? I don't know if you watch any of the Corridor crew videos, right? So they went out to make a stylized anime version of a story. And so this is from some of the behind the scenes making of that, right? So kind of the idea was that they got the costumes and they took pictures of them, video of themselves in front of a green screen, making these super stylized motions. And they took lots of test footage of themselves, right? And this is the kind of result they got out of like the diffusion model directly, right? So they trained both on their own, you know, actions, but also by this, like I think that there was a particular anime that they liked that they trained on the style of that anime. They did a sequel to this where to get around some of the questions about the ethicality of training on some copyrighted video, then they asked an artist to make a bunch of drawings in a certain style and they redid another video like that. So here, this is basically just like frame by frame, you know, versions of the test footage. And they were very careful to choose like outfits that were super bright, you know, these very stylized anime-like poses. And you can see that at this point, you know, there would be a lot of stuff to do to, oops, I jumped to the actual thing. There would be a lot of stuff to do to video or an image like this to clean it up, but these guys are visual effects like YouTubers and professionals, right? So then you can say, okay, now I'm going to do traditional, like removing all the background of the green screen. I'm going to do some sort of like, you know, in-betweening of motion and so on. And so this is a clip of their result, which I don't know if the audio will play very well on the recorded video, but it should be okay in the classroom here.
The creator dealt us the same hand of cards. I just like mine better. You missed the
So they stylized, so everything here is AI generated, right? But it's not all done at once. So they did the AI characters in front of a green screen, and then the background is also like an AI generated background. And then they have like extra stuff like camera moves. You're gonna see like there's one point where this guy thrusts out his arm and he does like this little motion little thing that's like put in later. But the, you know, kind of whole like over the top expressions of the face and so on are all done with careful training. Like this. Like this kind of speed lines and so on.
Here, in this holy house, in front of our Father and the Creator themselves, with a crown, the throne, and the lives of millions under His rule. I challenge you, all. You know not what you do. I challenge you to rock, paper, cross, blade.
So basically, you know, this is this whole like 5-minute long video where, you know, all the stuff like the camera moves and the little extra accents and stuff, that would all be difficult to generate like frame by frame with a single model, right? So these guys are using their knowledge of compositing to say, okay, we're going to generate all the foreground characters, now we're going to generate all the background, then we're going to add in all the extra stuff, right? Another thing that I thought that I watched too many of these this summer is the Harry Potter Balenciaga type thing. So if you haven't seen this.
Well, Balenciaga, Harry. What is the difference, Father, between H&M and Balenciaga? After all, for the well-organized mind, Balenciaga is just the next great adventure.
You'll soon find out that some fashion is better than other, Potter.
There is no good and evil. There is only Balenciaga, and those two we seek.
So again, this is a combination of a bunch of different tools, right? So first of all, my understanding is that there's only really one still image being generated for each of these things. And then there's like the slow push into the character or push out. And then there's this extra thing where they do animated lip sync between some voice to, or some text to voice and the character. And there's also this thing where the character like slowly turns its head and looks at the camera. That's all done like kind of offline with some separate like, you know, again, deep learning based pipeline. But the only generative part is the single image, right? And I believe that the way that the images are generated is also basically, so there's this tool, and I think this will work. Well, let's see here. Let's try in Midjourney maybe. So if I go back to Midjourney, get out of here, carrot people, and I say like describe, and then I can, let's see if there's any good picture I can upload here. Well, okay, here. This is actually an AI image that I put in here. So what you can do is you upload an image, and then this is kind of like going through a model where it tries to figure out the best corresponding, what happened to my prompt here? Oh, jump to present, yeah. Huh. Did I miss my description? Maybe I typed it in the wrong place. Let's try this again. 132 messages. Oh, wait, here's, where's my sheep? Right, okay. So here, this automatically generates a text description of the sheep, right? A sheep sitting in class, you're looking at people in the style of the Helsinki school, whatever that means, English major, photorealistic accuracy, chemical reactions. I mean, not all this stuff is actually, you know, kind of like real. But then the idea is you say, okay, I take an input image of Harry Potter as a source image. I generate these like complicated text prompts. Then I feed that back in with like the additional prompt of, you know, like Balenciaga type stuff, and then I make these other things, right? So there's a whole pipeline. If you're interested in learning how to do it yourself, I did find a YouTube video that shows how to basically do X by Balenciaga. So if you go to this, not only do you see the Harry Potter by Balenciaga, but then there's like a thing that will kind of like walk you through what you need to do in order to make Balenciaga videos yourself. And so, uh-oh, my YouTube ad blocker is not working. Anyway, so again, this is kind of like my goal for the next homework is to just have fun with this stuff, right? I don't necessarily need you to go to any sort of like crazy effort to retrain things. Well, if you're doing some sort of like textual inversion or DreamBooth or LoRA, maybe you will have to do some sort of mild training, but I don't want you to spend like days and days on your computer doing it. I think it should be less effort, hopefully, that it took you to train like the GANs, for example. So that's the plan. Any questions or comments? All right, so I'm going to stop the recording.